Again, this is Mr. Ryan on Thursday, April the 2nd for geometry class, and we're now at 11.4 called proportional partitions. So this starts on page 540, and remember, get your calculator in hand, you're really going to need it, and your notebook, and just take your good notes and your good homework, and you'll be done with your homework to turn in today. So let's first look at this side splitter theorem, which is on page 540, and we're assuming that the top triangle here, ADE, is similar to the complete triangle ABC that includes the smaller triangle. And the reason we can say that is the DE and BC are parallel, and the corresponding side angle B is congruent to angle D, and angle E is congruent to angle C. So by AA, we do indeed have similarity between the small on top triangle and the big triangle. Now the side splitter theorem says if DE is parallel to BC, then AD, the top triangle side, over AB, the whole side, is equal to AE on the other side over AC, the total length on the right side. Okay? So now, if we have a general triangle with two parallel lines, and we have on the left side the parts of the side being V and W, and on the right the parts of the side being X and Y, the whole side on the left being U and the whole side on the left being right being Z, we can get these kind of proportions. V, the top over U, the whole left side, is equal to X, the top over Z, the whole right side, is equal to S, the parallel line, smaller segment, over T, the bottom line segment. Now, as the book shows, we have all kinds of proportions which are true, such as V over W, the top over the bottom part, is equal to X over Y, and we don't use all of these, so let's just go and see. You can look at these in the book on page 540, but let's just go use them as we need them. Okay, so for example 1, we have AD on the left side, 7.2, DB equals 4.8, AE equals 10.8, and EC is our X. So top part 7.2 over bottom part 4.8 is equal on the other side to proportional to 10.8 over the bottom part EC. And cross multiplying, we have 7.2 EC is equal to 10.8 times 4.8, which is 51.84. And dividing both sides by 7.2, we have 51.84 divided by 7.2, which is 7.2. Okay? So now the converse of the side splitter theorem is saying that if we have this proportionality to work, AD over DB on the left equals AE over EC on the right, then we can say that DE is indeed parallel to BC. That's the side splitter corollary. Okay? Now example 2, if we have 9 over 6, that would be WV over WX, is equal on the bottom to 15 over 10 ZV over ZY, which is simplified. They both simplify to 3 over 2 on math enter if you would need to. So we can then indeed say that XY is parallel to ZW. Now on the corollary to the side splitter, if 3 or more parallel lines divide transversals into proportional parts as shown over here, then we can have on the left side P over Q is equal to proportional to R over S. Now for example 3, we have the trapezoid turned on its side with the top part of 335 for the left and then the right part 1005, and the corresponding bottom left part is 440 over X, the corresponding right part. So from our side splitter theorem, we have 440 over X on the right equals or proportional to 335 over 1005. So cross multiplying, 335x is 440 over 1005 dividing by 335, and do that just that way in the calculator. 440 times 105 divide 335. Make sure you can get 1320. Okay? Now our next theorem is called the triangle angle bisector theorem. And if we have a triangle where the top angle is bisected, then if AD bisects angle BAC so that angle 1 is congruent to angle 2, then the bottom parts, notice BD over the whole bottom part, CB, is equal to the sides, AB over AC. So example 4, if CD bisects ACB, then we're given a side on the right of 3, the bottom side 4, and we know from the right triangle theorem that AB is 3 squared plus 4 squared, 9 plus 16 or 25, and so the square root of 25 is 5. And as shown, the whole AB is 5. So we can break that 5 up into x plus y equals 5, and leave x by itself, but make y equal to 5 minus x. So there we have the things that we need to work the theorem. So x over 5 minus x is equal to the sides 3 over 4. And cross multiplying, we have 4x equals 3 times 5 minus x, or multiplying through 15 minus 3x. And adding 3x over on both sides, we end up with 7x equals 15, x equals 15 over 7. 7 into 15 is 2 with a 1 remainder, so it's 2 1/7 inches. And y is 5 minus 2 1/7, or 4 7/7 minus 2 1/7, which leaves us with 2 6/7. And you can see that x and y add back to 5. Now starting on the homework on page 543, we're going to use the corollary to the side splitter, and all they're asking us to do is remember that w over y is indeed equal to x over z, because all 3 lines are parallel and they're cut by 2 transversals. Now on our typical triangle, which we're going to see a lot of, triangle ABC with the top triangle ADE, we know that AC, the whole left side, over AD, the top part, is equal to AB, the whole right side, over AE, the top part. And we know that. That makes sense. Now then also AD over DC, the top part on the left over the bottom part on the left, is equal to AE over AEB, the top part on the right over the bottom part on the right. And we've seen that. And then DC over AC, okay, so the bottom part over the whole left side, then would correspond to EB, the bottom part on the right, over AB, the whole part on the right. And of course, BE over CD, the bottom part on the left to the bottom part on the right, is equal to AE over AD, the top part on the right over the top part on the left. Okay? So those all make sense from what we've seen. So now in 6, if line segment AG bisects the whole big triangle DAG, angle DAG, then EH, which is E is in the middle of that farthest right parallel line, EH over AH, that part on the left side of the bottom, on the bottom part, is equal to BE from the right part that's corresponding to the middle over AB. And AJ, the whole left side, or the whole bottom side, over JG, which is the bottom part to the middle, is equal to AD, the whole top side, over DG, the right top to the middle. And AB, the top far right part, over BC, the middle right part, is equal to AH, the bottom left part, right part, over HI, the middle right part. And CD, the top left part, over AC, the whole top part, is equal to JI, the bottom right part, over AI, or AJ, the whole bottom part. Okay, so those I think you can make sense of. Now for 8, determine whether EF is parallel to BC based on whether the proportions are equal. So 2 over 4 EB over EA on the left side is 3 over 6, or CF over FA, and those both equal to a half. And so by our side splitter theorem, they are indeed parallel lines, EF and BC. On part B, we have 6 over 10 EA over EB is equal to 3/5 simplified, and we're checking now AF over FC, 8 over 12, but that divided by 4 over 4 is 2/3, so those two pairs of sides are not in proportion, so this is not going to be parallel lines. And then for part C, we have BE over EA is 4 over 6, and AF over FC, or no, FC over AF is 2 over 3, and they both have a proportion of 2/3. So yes, EF is parallel to BC. So yes. So now problem 10, we have the bottom part X over the bottom part 12 is equal to the left side 21 over to the right side 14, and the angles are bisected. So this proportion should hold, so we can solve for it. 14x is equal to 21 times 12, and 21 times 12 divided by 14 on your calculator, make sure you can get an 18. Okay, now in problem 12, we have 3 sets of parallel lines, and we have 2 sets of 2 parts on top and 2 parts on bottom. So the left part over the right part on top, 8 over 20 minus x, is equal to 10 over 15 on the bottom. So cross multiplying, 10 times 20 minus x is 8 times 15. Multiplying through on the left, 200 minus 10x is equal to 8 times 15 on the calculator, or 120. Okay, subtracting 200 from both sides, we get negative 10x is negative 80. Dividing by negative 10 on both sides, we get x is 8. So on top, it would be 8 and 20 minus 8, or 12. So that 20 minus x would become 12. Now on 14, we have 2 parallel lines and the side splitter theorem working, so that 8 over 5 is in proportion to y over 10. Cross multiplying, 5y is 8 times 10, or 80. Dividing by 5, y is equal to 16. But the whole distance, y plus 10, which in the book is called x, is now 16 plus 10, or 26. Now on 16, we have our parallel lines again. So 7 over y equals 5 over 10, and they're cross multiplying. We have 5y equals 10 times 7, or 70. 70 divided by 5 is 14, and the whole top side, x, is 7 plus 14, or 21. Now on 18, we have the triangle ABC with the 2 parallel lines, DE and AC. And notice the left side has 4 and x minus 12. The whole right side is called x. And so BE is told us to be 6, and that makes EC x minus 6. So we can set up the proportion as 4 over x minus 12 equals 6 over x minus 6, cross multiplying. 6 times x minus 12 equals 4 times x minus 6, multiplying through. 6x minus 72 is 4x minus 24. Subtracting 4x from both sides, we have 2x minus 72 equals negative 24. Adding 72 on both sides with your calculator, 2x equals 48, x equals 24, and my EC back there, the x minus 6, is 24 minus 6, or 18. Okay? Now in problem 20, we have the bottom in 2 parts. XY is 2a, and YZ is given us as 3a. RS is given us as x, and therefore that makes ST the whole distance 15 minus x, because the whole side RT is 15. So on the bottom we have 2a over 3a, and the a's cancel there, equals x over 15 minus x. So we can cross multiply. 3x equals 2 times 15 minus x. 3x equals 30 minus 2x. Adding 2x to both sides, 5x equals 30. Dividing by 5, x equals 5. So on the top side, we see x is 6 and 15 minus x is 9. 6 over 9 is in proportion to 2 over 3. On 22, we're told that the bottom breaks apart with the angle being bisected at the top. The two parts of the on the bottom is 5x and x plus 2. The sides are 15 and 3x. So the triangle angle bisector theorem gives us that 5x over x plus 2 is 15 over 3x. Cross multiplying, 5x times 3x is 15x squared equals 15x plus 2. And 15x squared multiplying through is 15x plus 30. Now, because these are all numbers divisible by 15, we can simplify this down to x squared equals x plus 2. But of course, to solve it as a quadratic equation, we have to subtract the x and subtract the 2, bringing it all over to the left side as x squared minus x minus 2 equals 0. And then we factor it with x minus 2, x plus 1, and x minus 2 equals 0 gives us x equals 2, which is our only positive number. So that's what we have. So the sides would be 15 and 3 times 2 are 6. And the bottom would be 5 times 2 is 10, and x plus 2 is 4. Now in our last one, 24, we're given several things. We're given AD is equal to 3, BE is 4, and EC is 6. So we can set up BD over 3 equals 4 over 6, or cross multiplying 6BD is 12, and 12 over 6 is 2. So that gives us the top on the left side, BD is 2. Now they also ask for AB, which is easy, just add up the left side numbers, 3 plus 2 is 5. And BC is add up the right side parts, 4 plus 6 equals 10. Now the last thing we have to find is the bottom, AC, and AC over 5, the line segment for DE, equals 10, the whole right side over 4, the top part, which is one of the proportions from our first page. So that gives us cross multiplying 4AC is 50 over 4, and the last thing we need from this is AC equals 12.5. Okay? Now make sure that you have your parents or yourself scan and copy your homework and send it all to gryanrca@gmail.com for your Monday through Thursday classes. Thank you very much. God bless you. Stay healthy. I'm praying for you.